Hello, everybody. Good morning or good afternoon, good evening, depending on where you are joining us from around the world. Appreciate you taking time today to join us for this webinar. If you signed up to join, hopefully you're joining this topic, which is commercial equipment manufacturers and how you can create new revenue streams with Edge ML anomaly detection. And so we'll dive into that topic. Some of the questions will be technical in nature. Some of them will be approach or process in nature, and some will be business in nature. So hopefully we get through all the questions that have been submitted so far before we even started. I'm your host. My name is Jim Hassman. I'm the president and chief revenue officer of Blues. And joining us today, two guests from Edge Impulse, a Qualcomm company, is Alessandro Grande. He's the director of Edge AI developer growth, and Alexis Suzette, who's the director of product management. So we have some guests with us today that have a lot of depth. The one challenge we have is we don't have a lot of time, so we'll go as far as we can. At the end of this, we will put up some contact information in the chat in case you guys want to reach out directly to Edge Impulse for additional questions or Blues. So with that, I'd like Alessandro and Alexis to do a brief intro of themselves, and then I'll cover just a quick overview on Blues after they do that, and then we can get into the topic.
All right, Alessandro, would you like to go ahead?
Sure, I'll get started. I'm Alessandro Grande. I'm heading the product management for Edge Impulse, the product, and effectively looking at ways of growing the developer base and really making it easier for everyone to develop AI models. I've been with the company for about 5 years now, so it's been interesting to see the journey of many of our customers that went from prototype to production in this time.
All right, and my name is Alexis. I'm the director of product management here at Edge Impulse. I only joined recently, only 2 months in the company, but came in to bridge the gap between sort of the larger businesses that we do with Qualcomm and the Edge Impulse platform, as well as designing new solutions. So we'll talk about that today. And in terms of my backgrounds, the last couple of years, I was the CTO of Unabiz and Sigfox. So based in Japan and France. And prior to that, I was working at Soracom. I was leading their European and APAC regions.
It's a small family. I mean, we have partnerships with pretty much every one of those names you just mentioned. I've been at Blues for just over 4 years, and since I got here, we've had a relationship with Edge Impulse like for the entire time, and there's been a lot of we share a lot of friends between the companies and customers, so it's been a great journey so far. For those of you that are new to either Edge Impulse or Blues, I will just give you the very quick overviews on Blues. We're here to hear about Edge Impulse and building AI anomaly detection and generating new revenue sources, but I don't want to skip over what Blues is. Some of you may be thinking, what is Blues? I'll just share a quick slide or two. Hopefully you can all see that. I'll just say at a high level, the way to think about Blues is a device to cloud system. We're not a modem, we're not a module, we're not just a SOM, we're not an IoT platform, we are a device to cloud system. The Blues technology exists to make it easy for companies who have physical products or physical assets that they want to actually extract data from, to do that very easily, to do it economically, to do it securely and at scale. And so we do have a couple of pieces to our product. One of the things in this device to cloud system, if you look in the middle here, is this little replica of a piece of hardware. And then over here, you see this cloud. This is the device to cloud system. The hardware piece is something we call the note card. I don't know if you can see this on my camera, but I'm holding one of them up here. I think it's the second one here in the list, the cell plus Wi-Fi. But they're all swappable. So if you look at the bottom of the note card, they've got that little bronze component to it. That's actually an M2 connector. And so somebody that's designing a product to use blues will simply build into their PCB an M.2 slot. And so you can slot any of these note cards in, and you can swap them out, by the way, if a device needs a different type of radio to communicate to the network, and you don't have to change your firmware. You just swap the note card out. So it's a swappable multi-radio approach to communications technology. And its whole purpose is to push data from the device to, in the case of Edge Impulse, to actually help shovel models and data back and forth from the cloud back down to whatever type of controller you might be using, whether that be a microcontroller, which many Blues products use, or a single board computer like a Raspberry Pi or something. Here's a bunch of features of the note card. I will just say that the cellular option comes with 10 years of data built into the note card. It's 500 megabytes, works in 137 countries, and it's got a whole bunch of things that you don't have to worry about. I won't read the whole list to you over there on the left. The Note Hub is a thin cloud client that allows you to activate and provision these devices, do over-the-air firmware updates, and also route your data wherever you would like. So you may be using one type of cloud instances, another customer might be using another. You can set these data routes up to push data to either a single end cloud destination or multiple. That's up to you. So that's the quick overview of Blues. What I'd like to do now is jump into our first question, which is about the topic we get, question we get all the time. In fact, the last webinar that I did a couple weeks ago, which had nothing to do with AI, this question got asked. So here's the opening question. I want to start, let's see. Let's see here. Should you be running AI in the cloud or on the edge? And so I will let Alexis take a stab at that one, and then there's further on questions we'll work through.
All right, so should we run AI in the cloud or in the edge? I think there's like a very simple high-level view of answering that question. And it's if you are potentially concerned about connectivity of your device, especially if the device is not constantly connected, then the answer is very simple. Like you really want to run as much intelligence as you can on device. The second part is, do you have data sovereignty concerns as well? Because running your model in the cloud will mean that a lot of data will go back and forth between your deployment environment and the cloud. And so definitely in that case, also you want to be careful and then run the model on device. There's a lot more complexity here. So we can go into some other contexts that are important to think about. You can have a very good connection, but that could be quite a pricey connection, especially if you're doing a visual model and transferring live video data all the way to the cloud is probably not very cost effective, especially if we're looking at cellular connectivity. So 5G, could provide that bandwidth and could provide these capabilities. But it truly isn't an efficient way of using the connectivity and basically running the intelligence. So in that case, also, like we'd really want to run the intelligence on device. Lastly, there's a couple of other areas where, for example, it could be a very small device. So we see like rings, for example, that are connected, but that will be running models. This kind of devices, like because they're battery constrained, keeping that connection up and running all the time to either a Bluetooth or even a cellular environment will definitely mean that that's really energy hungry and definitely wouldn't work in terms of an edge AI type of use cases, like where you would want to have that intelligence. So here again, like running on device. And lastly, latency can also be a concern. So if we're looking at devices that are looking at the heart rate and probably want to detect like issues with the heart monitor. Here also, like you really want to be on device. You want to have high performance, most likely using what we call an NPU. So this is something on device that will run the model in an accelerated manner. That's going to be very important to run on device because it's the latency is very important. You want to have the really quick reaction, the really quick decision making. So these are a couple of cases. There's a lot more where we want to run on device. But in terms of traditional IoT type of environments, I think it's always a good place to start where connectivity is a big question, and then the data sovereignty. Like these are two strong points to look at first in terms of making the decision to run on device or not.
Maybe a real real world scenario, peanut butter in my mouth. Um, let's say you have a manufacturing line that has a quality control inspection function in it. Can you maybe describe what's happening on the edge in that type of context versus what's happening in the cloud?
So here we're going to, for example, let's talk about a PCB manufacturing inspection. So you're going to want to use quality cameras in order to look at all the PCBs that are being manufactured and look at anomalies on these PCBs. So these are the type of models that we would train with data sets. So we're going to have that type of PCB that is being manufactured. We're going to create a data set where we're going to label all the potential anomalies that you can see. And we're going to train that model to look at these anomalies. So look at, pictures basically. So it's real-time video, but it's picture by picture. So you will look at the PCBs going below the camera and you will say, oh, this PCB has an issue here, there, put it on the side. Like it should not go into the customer's hands. So that's a model that we would train. And this model, yes, could run in the cloud. But that's going to mean that you would need a really fast permanent connection from the factory line to the cloud, which surprisingly is pretty hard to do even these days, like connectivity. I mean, we all experience it at home. Like we're hoping there is this webinar, we're not going to get connectivity issue, but all of us have it, right? When we're doing these video conferences. And it's the same for factories. Like it's really hard to have a stable connection. And it's great nowadays because with the latest advancements of chipsets, of ML technologies, we can actually run that anomaly detection model on device. And so the camera itself will be able to decide, okay, that's a good PCB or that's a bad PCB in this case. What's really good with that type of implementation as well is that we can connect that camera to the rest of the manufacturing line. And if there's too many anomalies, for example, like, you start to go into 20, 30% anomalies, the camera would send a message to the local management system and say, hey, we probably need to stop this manufacturing line. Like there's a big issue here. But vice versa, if you're not able to do this anomaly detection on camera, and like you have like potential issues here again, connectivity with the cloud, that could be an issue. You stop manufacturing, and that's a big issue. Like imagine an Apple, manufacturing these millions and millions of devices, and then they have to stop for like 5 hours. Like that's a big, massive business impact here. So these are like some of the benefits and use cases where we would want to run AI on the edge, and this anomaly detection in manufacturing is actually a very good example of where AI on the edge is truly beneficial and makes a lot of sense.
Maybe a question for Alessandro. Why can't you just push a model to the edge and just let it run forever?
Yeah, great question. If I may add just one bit to what Alexis said, an additional kind of angle, right? I think it's interesting. The way I look at it, right, when it comes to like edge versus cloud, is always that things should be considered, very well, right? Or very, very, you should always kind of keep in mind what the objective is, right? And so in certain cases, Alexis described this device manufacturing system, right, where you're kind of monitoring for anomalies. What happens if, for example, you're detecting something that you've never seen before, right? Like in certain cases, you could potentially instantiate or kind of call a model in the cloud, right, to like potentially get additional context. So one thing to keep in mind, right, is that it might not always have to be one or the other, right? Like you could also have a combination. So I think I always like to also mention that, right? Because I think we tend to like always like kind of exclude, right, or kind of build things or think about things in kind of exclusive ways. But actually, there is coexistence as well of these models, right? And I think some of the most successful use cases, right, can kind of like have this hybrid approach as well. So, but to kind of going back to your question, Jim, I think it's actually related to what I was mentioning, right? So let's say you are in a factory floor, right, and you are detecting anomalies. What happens if all of a sudden the manufacturing line is developing something new, right? And you're changing some of the processes. All of a sudden, the PCB that you're trying to detect is now different, right? It's a different color. It's a different manufacturing SKU. What happens then, right? If your model is one and done, right, and you've kind of deployed it once and you have no way of updating it, what are you going to do? Most likely, what this will mean is that you'll be in a situation where you can't detect any anomalies, right? Because everything is going to be an anomaly effectively, right? Because you've trained a model on a specific set of data, and in this case, all the data's changed, right? And so it's really important, right, to be able to analyze and kind of understand when a change like that happens, and be able to adapt, right? And so in this case, it means effectively updating the model, right? So again, in this case, what you would need to do is connect to the cloud and send the data to the cloud so that you can then update the model and then push it back to the device so that the device can become functional again, right? So yeah.
Well, you covered two questions in one, because the next one was what changes in production environments would require model changes, and I think you clearly stated what that would be. And I think to summarize, it's like, well, if there's a change in what the model is experiencing or being subjected to, it's going to need to know that. So probably a summary for that. Do you have any concrete examples that you've seen while at Edge or prior to Edge that kind of come to life for you?
Regarding this updating of models, you mean?
Yeah, the updating of models.
Yeah, I mean, it comes down to like a few different scenarios, right? It's either the environment is changing, right? So it might be that the conditions are changing. For example, a light blows up in the factory, right? All of a sudden you're dark, right, or darker than the system is used to. In which case, again, you have to adapt. Or it might be that the actual thing you're trying to monitor, right, or inspect is actually different, right, as I mentioned earlier. And then there is also the scenario of the sensor behaving differently, right? So over time, the sensor might become might kind of lose its ability to like detect in a certain way and might start like drifting, and so you actually have different detections that are due to like the change of the actual sensor itself, right, over time. And then there could also be cases in which the machine or the system in place, right, is kind of behaving differently in the sense that perhaps the machine is about to break, right, and it starts producing things in a different way from what you're expecting. And so these are all scenarios where you actually have changes, right? So you mentioned it, I think you described it very well, right? It's every time the sensor is basically seeing something different or behaving differently, right? These are all times when you need to adapt, right? But the most important thing, actually, I should say, is before adapting, you need to detect that something has changed, right? And so that's the first challenge.
Yep. And be able to present that in a way that the model can learn from it. A lot of Blues customers build their connected devices using Blues, using some type of host microcontroller, an MCU-based device. Some have used a single board computer like a Raspberry Pi. Can you explain the differences in the capabilities of like edge processing and what people might want to consider if they have an MCU-based device versus a single board computer?
Well, I'll take a start and then stop, and then Alexis, you feel free to jump in if you've got anything extra. I'd say, I usually think about like different classes of models, right? So we go from, different modalities, let's say, right? So we go from vibration, right? You're trying to detect vibrations of a certain, machine in a factory floor. And that's typically stuff that, time series data of that kind is typically stuff that you can run very easily on any microcontroller out there, right? And then there is, the kind of beyond that, there is the case of like sound detection, right? So you're trying to now detect a specific sound coming from a machine, or perhaps specific keywords, being spoken, or even, even more complex scenarios where you're trying to detect actually or understand natural language, right? And so when it comes to sound, right, I think there is a distinction between what can run on an MCU and what can't, right? And usually the kind of limitation there is around like your detection of events, right? Is something that an MCU can do. Long, detection or understanding of like sentences or phrases or even natural language, that's something that an MCU cannot do, right? So I would typically think about MCUs to do event detection, right, in that sense. And then when it comes to the more kind of rich scenario of like having a camera, video stream, right? That's when microcontrollers are perhaps less capable, right? Although we've developed as Edge Impulse, we've developed actually a couple of models for specifically this reason, right? To enable microcontrollers to do visual anomaly detection, right? And typically not something that microcontroller can do. Our model is called FOMO-AD, right? So FOMO anomaly detection. And these are models that are specifically built for running efficiently on an MCU, right? And really enabling an MCU to do this visual anomaly detection. Obviously, right, what that means is that given the constraint of the system itself, right, you're very constrained on the type of anomalies that you can detect, right? So we're usually looking at like, less pixels on an image, and so perhaps your anomaly cannot be very small, right? And kind of constraints like that. So again, when it comes to visual understanding of the world, right, typically you want to do that on a processor, a Linux based board, right? And not on MCU. But what's interesting is that in certain cases, it can be run on MCUs as well, right? So that's where there is some expertise needed around like figuring out if it's possible or not. But it's definitely an interesting space because there's a lot of potential there as well.
Yeah, we've
And
seen.
oh,
Yeah, go ahead, Alexis.
yeah, to add to Alessandro's, like what's really interesting these days is that we also start to see what we call model cascades. So these are models that will talk to each other and start to cascade sort of the decision making. And in these cases, like we even have boards where you start to have an MCU and a more capable CPU, NPU, even sometimes like something really powerful. So the space is becoming interesting because the modality of everything that you want to do, and especially if you start to look at robotics, for example, where you're going to want to have a lot of different sensors and make a lot of different decision making within one device. It starts to require kind of that combination of actually the different capabilities here. One thing we do with Edge Impulse is that we support optimizing for the different targets, and we actually support testing the performance of models on different targets. So that's a really good way to start as well, is building the use case, building the model, and then doing some performance testing to also see where it's going to run.
Yeah, we've seen on the microcontroller side, we've got a customer that makes these little buoys that they drop into the ocean that are monitoring weather, waveforms, currents, and because the device is not always connected to the cloud, sometimes it's floating out there, it's collecting data and it's actually running the models. And then when it gets into range again of connecting either via satellite or cellular, it pushes the results, the inferences back of these waveforms and the currents up to the cloud. And then they use the data to inform shipping route optimization, for example, or the potential development of a typhoon or a hurricane like conditions down at the ocean level. Another one is using, they've got like semi truck trailers. And when you speak about the potential to do anomaly detection using video image, these would be low pixelation images that are captured kind of like think like a hunting camera. But they're capturing these to detect, was there any impact, was there impact that happened to the trailer from something? Could be in traffic, it could be while it was parked somewhere. And is there motion? Is somebody breaking into it? So is another use case that they've had there. And the list goes on and on, but those are all really good examples of like MCU based ones. Where if you get into like sound and vision inspection, obviously you're going to want something more powerful than an MCU based approach. Next question would be, make sure I've got this. Oh, so one of the big advantages of AI is minimal connectivity requirements. So what should you be sending back to the cloud, and what's worth the bandwidth cost?
That's a very good question.
Good luck.
So yeah, no, from an architecture perspective, I like to start with the principle of, if you can do um, a lot of the intelligence on device, it's pretty good idea to do it actually, because these inference results are really what's valuable. But now that's where we start to get into complexities, right? So you have different types of inference results. One that I like to give is image inference results. So if everything is okay, the inference result has like a very high confidence on, anomaly detection, for example. Uh, Generally, like you might want to save the result of that inference. But that's pretty straightforward. That could be saved locally on, like, for example, an on-prem storage, and then you're good to go. But when you start to see like kind of like drift, as Alessandro was mentioning, from different perspective, could be a change of light environment, could be a change of the sensor, right? The camera is becoming older and is starting to drift in the quality that it's providing. That's where generally you want to start to upload more data to the cloud, and start to use that connectivity, because that's very valuable data to retrain the model and to improve it. So I think a good approach is like monitor basically the inference. Like look at the confidence in terms of the results, like build models that have that confidence built in, and start to make decision making on, if you start to get in sort of a lower type of confidence, it's a good time to save and upload the data to the clouds, and not just the inference results. So that's a simple high level example, but I think that's a good starting point in terms of, what strategy could be applied to especially save on these bandwidth costs, and make the best of the implementation.
Yeah, we always see in deployments, at least early on through the pilot phase and easy and sometimes early deployment phase, we typically see people ratcheting up the amount of data and the frequency at which they're sending it because they're trying to learn in that process, like where's the optimal set point of like how much do I actually need to be shoveling back and forth. And it's a learning process, like how much can I get away with not sending, because the I mean, we all want as much data as we can, but that's not always the right answer. um, Maybe next question for Alessandro, because you mentioned earlier that there's some device manufacturers who do use anomaly detection for quality control. Can you walk us through their journey? Like, what was their hypothesis? What did they learn? What were the big ahas? And what's the business value that they started to see? Maybe pick one example.
Yeah, I'm actually going to pick two because I think
Okay.
there's two different. No, but there's a reason for that. I think one is the more typical approach, right? Of one of our customers is effectively a big manufacturing of automotive parts, and what they do is effectively visual anomaly detection on plastic parts that they're producing, right? So this is a customer that has been doing this for a while, right? And in this case, the adoption of visual anomaly detection and edge impulse was basically due to the fact that they were spending thousands of dollars, tens of thousands of dollars on buying machines that basically were capable of doing this, right? And they realized that they could build this themselves and just save money, right? And more so, they actually realized that with using Edge Impulse, right? They started off with a pilot. They realized that with using Edge Impulse models, with building this themselves, they could actually achieve better results. And what this meant really was, in their words, it was $1 million saved every year, right? And this is just from fines that they basically didn't have to pay, right, to their end customer, right? And so they're manufacturing these plastic parts. Every time they would ship something that was manufactured wrong, right, they would receive a fine. And so with using better systems, right, on the edge that were capable of detecting these anomalies with more accuracy, it meant that they were just getting less fines, right, and actually saving even money on the machines themselves, right, because now they were building machines with much cheaper, or kind of more cost saving, more cost optimized, effectively, devices. So this is an easy one, right? It's like, you realize that something needs to do, you need to do some visual anomaly detection, right? Because otherwise you're getting fined. You try to do it somehow, like, by buying something right off the shelf. You realize that it's very costly and actually not that effective. And then you just develop the machine yourself and you kind of do that, right? And it saves you a lot more money. But I wanted to kind of point out another one that I think is another interesting use case. This is a big manufacturing, or not, sorry, I shouldn't say manufacturing. This is a major industrial laundry operation, right? And what's cool here is that they started off with basically, we want to enable our systems to detect effectively stains and other, rips and other things in the other anomalies on their production, on their kind of laundry system. And what it turned out, actually, what turned out in the end is that they realized that this was so effective and so good that they decided to build a business actually from this. And so what they did, on top of like their laundry, the laundry operation, they actually built out machines with this capability that they started selling to customers, right? And so they became effectively someone that went from solving a problem to actually realizing that this is something that can scale. And they actually built another business out of it. What's really interesting here, and to me, is like one of the key benefits of AI in general, is the fact that there's a lot of potential for innovation, right, and for kind of disrupting the system, right? These machines, these laundry machines, have been existing for years, right? But now you can make it better, you can make it cheaper, you can make it more effective, and you can actually build a business out of it. So I think that's why I wanted to point out that there are some really interesting use cases where people are actually evolving and building businesses out of it.
That's amazing. Is there anything in the power grid monitoring space that you guys have seen at Edge Impulse, any use cases there? And then also airport equipment optimization?
Yeah, we had quite a few actually. We had one really early on that we worked with. It was Isoelectro. It's a company in the east part of Europe, and they built basically these power line failure systems that were monitoring for effectively fires or kind of disruptions on the lines. And what was really interesting there, right, was the fact that they were trying to build something that could persist and kind of didn't require a lot of support, right? Because these things are out there in the middle of the forest somewhere, right? And you don't want to be sending people over to change a battery or change the system, right? So they built something using our technology with a silicon vendor, actually Nordic in this case. So an MCU based system, right? Very low power. And it had like, they proved that this had like 20 years of battery life, right? And so the interesting thing there was not so much the saving, right, or the kind of monetary effects of this, but the fact that this could actually work, right? Because anything else would have just not been scalable, not been effective in actually deploying at a large scale. We just had another one that we worked with actually recently as well. That is still similar. They're trying to. This is gridware, another customer that tried to, or is building something to detect fires in power lines, and it's, you know, they're being effective in developing this with again a microcontroller, right? So talking still about low power, very high efficiency systems, and so yeah, we're seeing quite a lot of that. You mentioned airports. We did work with one of the major airports in Canada, but to be honest, I don't remember exactly what they built there, but it is interesting. It is a space where there's a lot of potential, I think. I don't know if Alexis has any more to add to that, or in general, like to these use cases.
No, in general. So yeah, in terms of airports, well, one thing that I've seen that's really interesting is sort of visual detection of tools that should not be around the airplanes. So it's quite interesting because whenever somebody's maintaining an airplane, they come in with a toolbox, they do their work, then they go back to the office and, you know, they've done their job. And then they notice, wow, a hammer is missing. Where did you leave it? Or wrench? Is it in the engine? Oh, the airplane cannot leave. And so there's a whole like really strict process there in terms of detecting basically if these tools have been left on site. Another interesting use case that's related to that, which is not directly related to airports, but it's a use case where whenever they are manufacturing or fixing airplanes, they need all these like really specialized bolts and parts that they need for the airplanes. So one of the companies that I met, they actually use visual detection to look at how many bolts are left into the box. They use that data to sort of create predictive deliveries. And they do a bolt as a service, basically delivery, and they guarantee that whenever they're fixing or manufacturing airplanes, there's always going to be bolts available. Because it's amazing. Like a simple bolt that's like a $1 piece can just ground an airplane for days if it's not there and delivered. So the really interesting use cases, right? Where it's not always anomaly, but you know, we can go also detecting like location of parts or like, you know, usage of parts and seeing if there's enough and guaranteeing that the supply chain basically is running all the time.
Really great examples. I'm sure we could just go on and on and on about things that we've been exposed to. If any of you that are listening have use cases that you would like us to talk about with you, please drop those in the chat. We'd be happy to get back with you at the end. We will put some contact emails or so you guys can get in touch as well that way if you want to do it after the meeting. But for someone who's been sitting here listening to this saying, oh, this all sounds great. How do I actually build what I want to build? Can you give us maybe a high level view of what it takes to build, let's just say, an anomaly detection solution using Edge Impulse? And what does that process look like? How long will it take?
Awesome. Yeah. What's really cool is that you know, Edge Impulse, with Edge Impulse you can experiment for free, right? It's open to anybody. So you just go to the sign up link that's just been shared on the chat, and you can get started for free, right? Anybody can get started for free, and you can really start experimenting, you know, from day one, right? With a very small data set, right? What's really interesting for specifically for visual anomaly detection is that you don't actually need a lot of anomalous data. What's really cool is that you can build these models just using nominal data. So you can use data of like the, you know, the parts or whatever you're trying to monitor, the kind of non-broken parts or you know, faulty parts, and you build a model basically that's able to understand when anything is different from that, right? So what's really cool there is that you know, it doesn't require someone to know what the anomalies are going to be, right? And that's really powerful because usually, right, you don't have a lot of examples of anomalies, right? And also, or you don't have all the examples of all the anomalies, right? Because you don't really know how the machine could break, what could happen in the process, and so what we enable is effectively to deploy, you know, literally in a few weeks, a model that can detect anything anomalous, right, and kind of flag it to the user. And then what we could do with our systems is also enable the user to effectively connect back, right? For example, through Blues, and send data back when there is an anomaly, and then use that data to actually build a classifier that eventually over time is able to detect what type of anomaly it's seen, right? So, think of this as like a kind of staged approach, right? Where you kind of initially just want to make sure that any anomaly gets flagged, and then you're able over time to refine the model and actually have it detect and tell you what anomaly it was, right? And so you can kind of get started right away and then evolve the model and make it better over time. And that's the approach that most of our customers take today. And it, as I mentioned, it takes a couple of weeks, right, to get started with that, right? And as always, right, if you want to go to production and you're really serious about this and you want to test it well and kind of make sure that you've got all the monitoring systems in place and so on, that can obviously take a few months. But what's really cool is that you can test this out in real production, right, or in a kind of environment that's very close to the production environment, in just a couple of weeks, right? And to be fair, like you can build a model, an anomaly detection model, in probably about an hour, right, or even less. Then it's just about refining it, and that's really cool. That's really where we've been spending a lot of time, right? How do we make that process as quick as possible, right?
That's great. We're 2 minutes to time here. There was a couple questions that people put through the Q&A prompt. I answered one of them. Let's see. Let's see here. Maybe if people are looking at the chat here in the in your window, let's see. I can probably repost this. Yeah, I'll repost this right now. I put a couple of links for you all. I guess I need to repost them. One is if you want to try Edge Impulse on Blues, you can try the Edge Impulse for free. Blues, you can get one of these little inexpensive starter kits. It comes with a host microcontroller, a PCB, a note card, some antennas. You can power it through your laptop and try it that way. So that's really easy. And I'll also put a link for the documentation of how to use Edge Impulse on Blues. So you guys have a link to that as well. Let me see if I can repost these right now. Maybe just as I'm doing that, just to close this out, for someone listening today who wants to start adding this kind of intelligence, what's the one thing they should do to get started?
I think it's great to think about the use case as a first step, and look at the sensors that would basically serve that use case. Like with Edge Impulse, like there's a lot of example projects. So actually, in terms of training a first model for a specific use case, that's quite straightforward. But ensuring that the hardware, comes behind it, I think is a really good first step to do. So usually when people ask me, I say, well, start with the sensor, like figure out which sensor you need, and then therefore the hardware and the model will naturally come from it. Alessandro, what would be your first advice on getting started?
I would say, I think it's kind of it should go without saying, but you should just get started. I think a lot of people when they think about this problem, they kind of delay the start, right? They think they need to collect a lot of data. They need to learn about Edge AI. They need to learn about Blues, right? They need to kind of have everything figured out before getting started. I like to always, at least myself, start by doing, right, and kind of test stuff out, test the tools out, figure out what the capabilities are and what the constraints are. So I would say, just sign up, right, and start playing around, and don't be scared, right, of perhaps the learning curve at the beginning. We have a big community, right, that can help. We have a lot of experts that can kind of sit down with you and take you through the initial steps. But I would say just reach out or start playing around. Just do it as soon as possible, right? Because that will really inform decisions for the next steps.
Excellent. Well, we're right at time. I'll add my one thing to this, and that is to go back to grade school or elementary school when you learned the scientific method, and that is develop a hypothesis. You know, I believe that if we apply this technique to this thing, that the benefit, whether it's an economic benefit or an operational benefit of doing that, will be the following. And start with that. It's kind of amazing to me how many projects I get into and I say, can you tell me about your business case? And they'll say, yeah, we really haven't thought much about that. We're just playing around. And so I think if you're doing something that is going to be of scale and of impact, make sure to develop a good hypothesis. You might be wrong in your hypothesis. That's what the method is for. And do exactly what Alessandro said. Don't be scared. Just jump in and start testing. So thank you all for your time today. There were a couple other questions that got submitted that we won't have time for. I will make sure that that we reach out to you and get those addressed and point you in the right direction. I don't know, Alexis or Alessandro, if you wanted to put any type of contact info in the chat right now before we close the session for everybody, but I'll drop mine in here as well.
Yeah,
So
I'm gonna drop mine as well.
if you have, if you guys have any questions, don't hesitate to reach out. We'd love
We
to hear
can.
from you.
I don't
We
think we
can post to
can.
everyone, yeah.
Yeah.
So we'll let you post for us, right?
Okay, let's see here. I can post this.
In the meantime, Jim, thank you so much for having us. Blues team, you know, we always love working with you guys. So thank you for having us, and it was a pleasure to talk through these interesting use cases.
Likewise, for those of you that are work at other companies and don't work at Blues and at Gimpulse, we are extremely close as companies. We're really good friends. We enjoy working together. So if you have a challenge that you want to throw our way, we'd be happy to hear from you. Again, thank you guys very much, Alexis, Alessandro, for joining us, and for all those who took time out of your day. Have a great week.
Thank you.
Thank you.